So for this answer key, I already have a video of the constitutional isomers of heptane, so I'm not going to go ahead and recreate that. We had 9 constitutional isomers of heptane, their names and skeletal structures in a previous video. So hopefully on this exam you already knew those and had practiced those so you could write them out without too much trouble. Now the interesting part about this question is the next question, question 6, asks for a chiral molecule. And if you were to examine all of the different isomers of heptane, this is one of the ones with a chiral carbon in it. If you look, this is 1, 2, 3, 4, 5, 6. This is a hexane. And it's got a methyl in the 3rd position from the end. So good old 3-methylhexane. And if you look at this carbon here, the 3rd carbon, the one with the methyl sticking off, it's got 4 things attached to it. It's got a propyl, which is carbons 4, 5, and 6. It's got the methyl that's hanging off to the side. And then it's got an ethyl group, carbons 1 and 2 together. And then there's also a hydrogen there to fill the octet. So this is a chiral isomer of heptane, 3-methylhexane. And if we're to draw the Fischer projection, you draw a T, and the chiral carbon is in the center. It's really helpful to put the hydrogen in the top, because then it's behind the plane and you have proper perspective. So this is the proper perspective with the hydrogen in back. And then if we're going to go clockwise to get the R isomer, you would then put in whichever group you wanted to start, but I would start with the larger group, the propyl group. So 1, 2, 3 carbons here. And then if that's priority number 1, then we go to the next biggest group, the ethyl group, be priority 2. And then the methyl group, so this is essentially already a methyl group with CH3 there, that's number 3. You can see that going around the clock clockwise, we go group number 1, group number 2, group number 3, and then the hydrogen group number 4 is back. So there's the Fischer projection for the R isomer of 3-methylhexane. One of the other chiral ones, and it might be the only other one, I forget whether there's 2 or 3, but if you do a 2,3 dimethyl pentane instead, then the 3rd carbon is again chiral. Now you're going to have essentially an isopropyl, an ethyl, a methyl, and a hydrogen all on that 3rd carbon. So this one is one that you can also do a Fischer projection of the R isomer pretty quickly. Put the isopropyl group number 1, the ethyl group is number 2, and the methyl group is number 3. And I'm sort of drawing these as pseudo-skeletal structure Fischer projections. Other people might want to see, like, rather than just leaving this as an end of a skeletal structure, they would probably want this to be written out as CH3 for the methyl there. For the ethyl, it would be C2H5, and for the isopropyl, you can write C3H7, or give it a little more structure as a CH3, 2. And if you work these guys out, you'll see those are essentially the formulas for isopropyl, ethyl, and methyl. So there we go with a little bit of an answer. Fischer projections for chiral molecules that are isomers of heptane.